Okay, so we're going to do 2019 question C2, the structural forms question based on shell structures. So we're going to start off by highlighting the key words. So basically it says, the image on the right shows a structure designed for a seating area in a garden. The projections of a similar structure are shown below. So that's contact. So basically this is sort of roughly what we're constructing. The curved surface is produced by translating a generating parabola ABC. So when it says translating the generating parabola, that gives us the idea that we're talking about a shell structure in a vertical position. Okay, so that would be a key part there as well. Along the parabolic curve DEF. So basically we know we have a parabola here, ABC, and a parabola DEF. In the outline, the end view, the dotted line shows the generating parabola ABC. So that's basically what we're talking about. B is the vertex of that one, and E is the vertex of that one. Okay, so basically E is the turning point, and B is the turning point. Draw the given elevation structure, draw the given end view, and draw the given plan. So we're going to do part A, B, and C to start off in this video. And again, typically, if they give us this order, that's the best order. So elevation, end view, and then plan. We may not be able to construct all of the elevation. I'm not sure. I haven't done this question before. We'll see. We'll surely do most of it, and then project down to get the plan. Okay, so our scale then is the other important thing. So it's 1:100. So basically that means 10 meters is 10,000 millimeters. So divided by 100, it becomes 100 millimeters or 10 centimeters. Okay, our height here, this line PQ must have something to do with part D. So we just need to think about it at the minute. So what we'll do is we'll come down, what's that, 11, so come down 120 from the top, and start to construct that from that. Okay, so move this to one side, and we'll start off by drawing my ground line across the middle. Okay, so I'll construct an XY line like so, and start off here. So we know our length is 80 plus 60 plus 20, so that's 160. We'll start off constructing basically a rectangle around which our surface will go. So for the minute, we're only worried about the 8 part. Right, and if we come down another 3, we have our line, sorry, a little bit off the screen there. Okay, we have our line for our parabola curve, right? And we may as well mark on these other points. So we have point 8 here to start. And I'll draw that like so. And we have another point 6. So I may as well mark this in at this stage, at least that way I won't forget about it. Now, the other thing that I probably would do at this stage is I probably will put in the line PQ, just to make sure that I've put in and haven't forgot about it. So we're told that that's 30 above us. And we'll just draw that in as a heavy line, because it's shown as a heavy line. Okay, so I'm just using my set square because my t-squared hits off the visualizer. So I'm just going to put that line in there, PQ, just so that I have it in. Something to do with what we're doing as part A, B, or C, but at least I have it in at this stage. I didn't drop these lines, which I should have. That's just so that it looks a little bit easier. So it's saying it said do the elevation first. So what we're going to do first is basically we're going to draw our parabola here, because it said that to do that first. So we have a distance here of 30, and that divides evenly by 5. So I'm just going to mark out 6, 12, 18, and 24. Now, what I might decide to do is, I might decide to do my division line methods. I don't think you should have to do it because it divides evenly, but they may decide in the exam that we should have split that to make sure that they were even. So a division line method for that side, just to show that we could do it, wouldn't have been a disadvantage. But basically I'm not going to do it today just for the sake of speeding us up. So 32, 48, and 64. So again, 80 divides evenly by 5. And I'm going to bring down these various points. Okay, so what I'm going to do now is I'm going to number these 1, 1, 2, 2, 3. So we're 1 and 1 cross, we're 2 and 2 cross, we're 3 and 3 cross, we're 4 and 4 cross, and then I have my point here. Okay. So basically we have our initial parabola curve. Now I could do two methods for getting the other side. I could mirror the cross, or I could just repeat the same method from the opposite side. For today I'm just going to mirror the cross, just for the sake of showing us how to do this. So I'll move this in a little closer just so that we can see. Okay, so we're just going to draw a light line across here. And both methods are perfectly acceptable, but sometimes students struggle to understand the mirror method, right, or use it a bit less regular. So what I'll do is I'll take my compass, I'll put in my green pen into it. Okay, so what we'll do is we'll set this distance here. That's the first one done. So all I'm doing is basically, because it's a symmetrical shape, I'm taking the same distance and marking it on both sides. Just double check that one's accurate. It looks very good. Okay, so we're going to sketch in our parabola on the other side. Now I'm just going to do the last bit light here, and we're just going to heavy to this line. So basically we know that it's there. So I now can take this side here and I can heavy it in, and what we know now is basically we have on this here various splits. So we have 1, 2, 3, 4. So what I probably could have done is use 4 divisions here. I probably would have got away with it. I like to use 5 because it's more accurate. So what we'll do is we'll draw in these various lines, and from that then we'll get these various points. So these are 2 meters apart. There's 4 of them in an 8 meter section. So 2, 4, 6, 2, and 3. So what I'll do is this one here is an important one. So again, they show it drawn as a hidden detail line. So it's important that I show everything the same way as they show it. So there's not an actual hidden, oh, I know what it is. It's basically, I was going to say there's not actually hidden detail there, but they're obviously assuming it's some sort of support for this structure that's for out in the garden. Okay, but the most important thing basically is to locate this point here. Because when we locate this point here, we can now join that down there. And I think that's our elevation. Oh, sure, I put that one. I was wondering what mistake I made. I put that one there in the wrong spot. So I'll get my Tepex and fix that one up. Sorry, I must have used a point that was incorrect. I was wondering why the gap wasn't looking even. So we'll get my Tepex and I'll just fix that up. I'm going to dry while we're waiting. So there's basically my elevation figured out. So that's part A done. So then they said you do part B. So draw the parabola that's going to translate so across the end view. So we're going to leave a gap maybe of about 10 millimeters, and I'll use my pink, and it's 10 centimeters. So let me zoom that out a tiny bit. Okay, so we're 10 centimeters here, and the height is the same. So bring this up. Bring this up. Again, I'm just using my set square to extend this on, just because it's easier than getting my T-square into that space. And what I'm going to do is I'm going to split that in two. So basically I have the 5 meter line down the middle, and draw just a center line here, long dash, short dash, and then basically I have my curve that goes in here. So what I'm going to do again is split it into 5. So 80 divides by 5. Now I didn't show my division of line method before, so just for the sake of anyone who doesn't understand what I'm talking about, or for the sake of anyone who, just for the sake of having shown that we can know how to use it. So what I'm going to do is I'm going to split it into 5 parts again. So I'm going to draw a random line there. My blue line there was random angle. I picked 5 equal parts, so we went up to 50 there. I will join this point down to so. And then I'll use sliding set squares or my adjustable set square to draw all them. So I just want to use my adjustable set square for today, just to be that little bit more accurate. So if I continue those down, that will just give me equal splits. So I'm only doing this not necessarily because I have to, but just in case you mark in the exams for showing that I can use the division line method, I have it incorporated there. So 50 then divides equally by 5. So 10, 20, 30, 40, 10, 20, 30. So I'll draw these on straight up. Okay, and then what we'll do is we'll now again, I could have used a mirror method for doing the other side. Completely personal taste. I'm just going to repeat the method for the other side. Okay, so we have our various spots. So again, we'll number them. 1, 1, 2, 3, 4, 2, 3, 4, 3, 4. So 1 and 1 cross, 2 and 2 cross, 3 and 3 cross, 4 and 4 cross, and the same again on the opposite side. So I'm going to sketch this. Now they drew this as a hidden detail parabola because it's not technically the complete end view, but I'm just going to draw it as a solid one just so that we can see it for the video. In this case, actually, this is part of the end view, and there would actually be another different sort of shape for this inner part here. So there we go. We've part A and we've part B done. So what it says then is project the plan of the structure. So if it says project, we have to use our 45-degree set square, and we'll start by doing the basics. So we'll get our center line, we'll get our outside edge, and again we bring down this, and we bring down this to start off. Okay, so there's a few ways we could go about doing this. Okay, so we have basically our outline for our plan as such. So again, what we could do if we wanted to, we could join the line for P and Q there just so that we don't forget it, but what I'm going to do is I'm going to leave it for the minute just to get the basics of the question out of the way first. So we have our line here as heavy. We can see that from the plan. That's our outline. And the reason that is because this is a full height parabola here and this is the full width. So what I'm going to do is I'm going to use one method to solve the top part of it, and I'm going to use an alternative method to solve the bottom part. Okay, so there's two sort of different methods for solving this part of the curve. There's only one real method that we can use for solving this section of the curve. So what we need to do is we need to say, well, if we were going to use these maybe purple lines that I have here for my heights. So what I'm going to do is I'm going to take these heights here and I'm going to call them 1, 2, 3, and 4. And what I might do actually is I'm going to maybe take a different color for each one. So the first one I'll leave purple. The second one will be sort of it's pinky purple. Third one we'll do will be a yellow. The fourth one we'll do will be a green. And we go with that to start off. So I'll just color this one here again. Okay, So hopefully, and again, if we do this as our notes, this will help us for revision. So if we use colour for our notes, it'll help us for revision. So what I'm going to do is I'm going to start with part 1. So basically the parabola has been the same shape, but what's happened is it's moved down along this. So instead of being a full height parabola like it was here, it's now only this height. So what I have to do is I'll take my compass, I'll adjust it out, and I'll set it to the height that I have. Right? And then from the top down, we'll mark that. So I'll mark that there. So I'll just bring down that line a little bit, just to meet it. And what I'll do is I'll write number 1 on that. And if that's the height, then this would be the width. So we'll write 1W there. Okay, so what I'm going to do now is I'll bring down this line here. And what I'll do is I'll take my width and I'll transfer it into plan. So that would be my height. Now I could do this on both sides. I'll just show you how to mark it on both sides. I'm just going to do it on the top for the rest of them, and you'll see why in a second. So that's my first one done. So what I'll do now is I'll take my second one. So I'll take my sort of slightly pinkier colour purple. I'll set my height. So again, it's coming down the way from the top. That's basically how much of the parabola would exist at that stage if I was able to slice it down. So if I got a saw and cut the object apart, this is basically what I would see at point 2. And if that was the case, that would be the width. So again, I'll take my width. I'll set it off here. And I'll just bring down all these lines to save me doing them individually. Okay, I'll go as far as that. I'll leave the other one for a second. So this is basically the second one. Okay, so I'll mark this off. And what I could do if I wanted to show how it was done, again might be easier, again use my slightly darker purple on, or pinker purple on that one, and my darker one on this one. So that line there is basically that line there, that line there, basically that line there. We'll write number 2 on it for the height, and then 2W for the width. And we'll repeat. So we'll do the same for the yellow. Now the yellow one, number 3, this here will also be number 3 on the other side, because that's symmetrical. So I can do 2 sides at once here. So what I'll do is I'll set my height. So again, we'll come down from the top. And I'll write 3 beside it. Hopefully that yellow comes out okay on the projector. I'll draw my line across. There's my 3 width. I'll set my compass to that width. Okay, so happy enough with that, and I'll mark it here, and I'll mark it here. And I can also do this side here at the same time. So the last bit I have to do is number 4. And what I've got now is the basic outline. So sketch that in. Okay, and I'm going to leave the other side for a second because I want to just prove how the other side could have also been done. So that's basically that, and then we have this sort of unusual curved shape here. Now, I only have one line here in the middle, so what I'm actually going to do is I'm going to split it into 2 more, because I don't think 1 is sufficient to get me an accurate mark for it. So basically, I know that this point here is the end point. And the reason I know that is because that's 0 height. If I came down 0 height, that would be 0 width. So that's basically going to curve like this. I could use just 1 point, but I think really I'd want to use 2 for something that's so steep. So I'd probably still use this one. I'm just looking at where it gets more curved. No, I'll pick 2 in the middle. So we have a gap of about 40 there. So I'll pick, say, 15 and 30. Okay, just to give me a little bit more accuracy. So I'll use a brown maybe for this one. I'll call this 5. And I'll use a blue maybe for this one. We'll call it 6. So all I do is I do exactly the same thing as what I've been doing. So I'll be taking my heights, whatever height it is that they are coming down, but this time instead of going to the ground, I'll just go to the base, or the bit where it cuts off, so the base of this cut angle. So there's 5. Okay, and we'll draw that across. And we'll take our width. And again, I'll project down 5 and 6 there as well. Okay, we'll do the same for the bottom. So there's 5. And then 6 is the darker blue. So 6 is quite short. Okay. Okay, so you can see that, and we'll take our width. So I'm going to sketch in my curve there. Now, really, if I want to be a bit more accurate, I'd probably get an extra line in here, because it's just hard to tell exactly what level of curve there. But we're just going to look briefly at how we could have done this as well in the next section of the video. So I'm just going to leave that unheavied in for a second, and I'll show us a brief video after this. That's how we could have done it. But basically, there's my question. So what I'm using is using a parabola translated along this to figure out my widths and plan, and that gives me my overall shape.